Hello everyone, I am Priyank Saxena. Today in this fourth day, we will be doing about one or two topics on chemical bonding. Now what happens up in this chemical bonding? The first thing which comes in this is Lewis dot structure. The Lewis dot structure, see how does it comes? Scientist Lewis has given up a dot structure. For example, hydrogen is there. We are having up a hydrogen. Now this hydrogen is having up atomic number 1. Helium having up atomic number 2, lithium having up atomic number 3, beryllium having up atomic number 4, boron atomic number 5, nitrogen atomic number 7, oxygen atomic number 8. Now what happens up here? See what we'll do, we'll write its electronic configuration in K11. First shell, 1 electron will come. Here, first shell, 2 electrons will come. Lithium, first shell, 2 electrons, second shell, 1 electron. Beryllium, first shell 2 electrons, second shell 2 electron. Boron, first shell 2 electrons, second shell 3 electrons. Nitrogen, first shell 2 electrons, second shell 5 electrons. Oxygen, first shell 2 electrons, second shell 6 electrons. Is it clear? Now, in Lewis dot structure, what do? We draw up a, we always draw up a, we write the element and we write the valence shell electron. Here valence shell electron is 1, here valence shell electron is 2, here valence shell electron is 1, here it is 2, here it is 3, here it is 5, here it is 6. And we represent these number of electrons with dots. For example, hydrogen, how many number of valence electrons are there? 1. So it is 1 dot. Clear? When it comes to helium, we will be writing up a helium. And how many electrons? So it is 2. Lithium, how many number of, see, overall electrons are 3, but valence electron is 1 only. So here, lithium it is 1 electron. When it comes to beryllium it is 2 electron. When it comes to boron it is 3 electrons. When it comes to nitrogen it is 5 electrons. When it comes to oxygen it is 6 electrons. Are you getting my point? Now what happens up here? See, this is Lewis dot structure for atoms. Okay, for simple atoms we can draw up. This is how we draw up a Lewis dot structure. Now we'll come to Lewis dot structure for molecules. Then we'll come to Lewis dot structures for complex compounds. Okay. Now what happens up here in this molecule? Lewis dot structure for homoatomic molecule. Homoatomic means same molecule. Okay, means molecule which is made up of same type of atoms. Now fluorine is there. Fluorine is having how many number of electrons? We know fluorine is having up a, the single fluorine is having up a 7 valence electron. 1, 2, 3, 4, 5, 6, 7. Another fluorine is there. 1, 2, 3, 4, 5, 6, 7. Clear? Now what happens up here? In this case, we'll join these 2 electrons. Okay? We'll join these 2 electrons to form up a bond. Why we are forming up a bond? Why can't this fluorine and another fluorine will remain single together? Means they will remain here separated, this will remain here separated. They are joining up right now over here so that their octet can be completed. See the valence shell, if I draw, this is right now, this will become up the valence shell of this fluorine. So how many number of electrons are there? 1. This will also be included in this fluorine. This is 2. This is 3, this is 4, this is 5, this is 6, this is 7, this is 8. And according to Lewis, if 8 number of electrons are there in your last shell or your octet valence shell, then your octet is complete. Same for this fluorine also. This will also consider 1, 2, 3, 4, 5, 6, 7, 8. So their octet is complete. Now, when it comes to N2, nitrogen, we know nitrogen is having up a, one second. Nitrogen is having up a 5 electrons. So it is 1, 2, 3, 4, 5. Another nitrogen is also having up a 1, 2, 3, 4, 5. Is it clear? Now what happens up here? See how many bonds will be formed. In between this, 3 bonds will be formed. Clear? Now if you come with the first nitrogen here, how many electrons will be there? 1, 2, 3, 4, 5, 6, 7, 8. Are you getting my point? So this nitrogen octet is complete. If you comes to another nitrogen, that will also have a 8 electrons. This is how a bond is formed. Why one nitrogen is reacting with another nitrogen to form up a bond, then to a triple bond? Because after forming up a double, triple or single bond, their octet is getting complete. Okay. Now when it comes to oxygen, oxygen is there. This is 1, 2, 3, 4, 5, 6. Every oxygen is having up a 6 electron. Another oxygen is also having up a 1, 2, 3, 4, 5, 6. Here we have a double bond. Clear? Now what happens up? Here also 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Cl2 also will drop the same. 7 electrons. 1, 2, 3, 4, 5, 6, 7. Here 1, 2, 3, 4, 5, 6, 7. So this is a single bond. This is how it forms up. Clear? Now what happens up here in this case? Clear? Now Lewis dot structure for a molecule. Now carbon. See carbon we can draw. How many number of electrons are there? There are 4 electrons. 1, 2, 3 and 4. We have a hydrogen over here. This hydrogen is always having up a single dot electron. Hydrogen is having up a single dot electron. Clear? Now how do we form? This is one bond, this is another bond, this is another bond, this is another bond. Now if you see how many number of electrons are there with this carbon, see this dotted area is the carbon line here. So 1, 2, 3, 4, 5, 6, 7, 8. Clear? These are 8 electrons. Now NH3. This is here we are having up a nitrogen. This is nitrogen. This is 1, 2. This is 3, 4. NH3. Here also, if we see with nitrogen, how many number of electrons are there? 1, 2, 3, 4, 5, 6, 7, 8 electrons. With water oxygen is already having up a 6 electrons. So here 1, 2, 3, 4, 5, 6. Another is hydrogen with 1 electron. Another is hydrogen with 1 electron. They will form up a bond. They will form up a bond. One here, one here. So this structure will look something like this. One lone pair here, one lone pair here. Here, one hydrogen, another hydrogen. These are the electrons. Is it clear? Now what happens up here? How many electrons? This is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is 8. Oxygen octet is getting complete. So the main thing over here is, see, whenever we form up a bond, whenever we form up a molecule, why it is being formed? So that the overall octet can get completely filled. Okay, the last. Now we'll do for some complex compounds. See, these are very, very important. What happens up in this ozone structure? See, ozone structure we have to learn. This structure is something like this. Oxygen. This is another oxygen. This is another oxygen. There is a double bond between 2 oxygen. There is a single bond between these 2 oxygen. Here we have one lone pair and one positive charge. Here we have a 1, 2, 3, 4 lone electrons. Okay. Here we have a 1, 2, 3, 4, 5, 6 and a negative charge. Now what happens up here? See, now what will happen up in this case? See, what will happen? This is one structure. Now the ozone will be having one more resonating structure. What will happen up in this resonating structure? See, whenever we are having up a ozone, we have another oxygen. Okay, we have another oxygen. Now, see why only there is a double bond between this and this oxygen. There can be a double bond between this and this oxygen also. Okay, this and this. So I'll draw the another structure in this. I'll reverse it. Now the right hand side oxygen is having up a double bond, and the left hand side is having up a single bond. So there is a 1, 2, 3, 4, 5, 6. There is a negative charge, and here positive charge. Now, whenever we have a more than one resonating structure, we'll try to draw up an equivalent structure. What is equivalent structure? Equivalent structure is what is common in these two structure. We'll draw up in the third one. Now when I draw up an equivalent structure, this structure will look one oxygen. It is common in all the. There is second oxygen. There is a third oxygen. It is common in all the case. Now what happens up here? There is a single bond. There is a single bond. Now what is not common? This double bond is over here. This double bond can come here in another structure. So what I'll do, I will give partial half bond to this one, partial half bond to this one. Is it clear? This is what it will happen. Plus both in this, the middle structure is having up a positive charge and the middle structure is having up a positive charge. So there is a positive charge which is common. One time negative charge is on the right hand side carbon, oxygen. One time the negative charge is on the left hand side oxygen. So what it will happen? We will give anything del negative charge and del negative charge. Del is anything which is lesser than 1. Anything. It can be 0.1, 0.2, 0.5, 0.99, 0.999, anything. Now what happens up here? See what we'll see. This is the equivalent structure. If someone asks that here in this case, what is a bond order? Bond order means what is the number of bond between any two atoms of this oxygen-oxygen bond. Okay. Now if someone asks here, what is the bond order of this oxygen and oxygen? Here the bond order is 1 plus half 0.5. So this is equals to 1.5. This is equals to 1.5. Now what happens up here in this case? See. If you see, this was for ozone. Now, how to find this del? See, what is the overall negative charge on these two oxygens? Here 0 charge, here -1. So -1. Here what is the overall charge? Del negative. So it is del negative, which is equals to -1. So our del value will be equals to 1/2. So the overall charge here will be -half and -half. This is how we see up a structure of ozone. Clear? Now we can do one more example like this. We can have one more example of carbonate. Now carbonate example will be having up a carbonate example will be having up a carbon double bond oxygen, single bond oxygen, del negative, single bond oxygen, del negative charge. Okay. Now again we can have a resonating structure. My double bond can come to this oxygen, can come over here. My double bond can come next time to this oxygen, and this oxygen. Is it clear? Now see, these are the three resonating structure. Just nothing is being changed. Double bond position is being changed from this carbon to this carbon to this carbon. Then we'll draw up a equivalent structure. Equivalent structure, how do we draw? We'll write all the things which are common. Now what happens up here? This is, see, what is not common? This double bond is getting shifted from here to here to here. So what will happen up? We'll give up a partial double bond to this carbon oxygen, and carbon oxygen. What is this partial bond? This partial bond is nothing. See, one bond is being shared between 3 locations. So this partial bond is 1 plus 1/3. Why? Because one bond is being shared between 3 locations. So 1/3 will be shared, 1/3 will be shared by all the 3. So that 1/3 plus 1/3 plus 1/3 is equals to 1. So here this is, now what is the bond order over here? Bond order over here is In between carbon oxygen, how many bonds are there? It is 4/3 or 1.33. Now one thing is also missing. All the three structure, your oxygen is having up a negative charge. Here this oxygen is having don't have any charge here, but here it is have a negative charge. Here also it have a negative charge. So what I'll do, I'll give up a del negative charge on this carbon, this carbon, this carbon. What is the total value of this del negative charge? What is the total value of this del negative charge? 3 del negative. This is equals to 2 minus 2 charge. So del equals to 2/3. Clear? So when I draw up a equivalent structure, this is carbon, this is oxygen. Minus 2/3 minus 2/3 minus 2/3 is the charge. This is how we drew up a coordinate, carbonate structure. Clear? Now the next thing is phosphate structure. Phosphate structure is PO4 3 minus. PO4 3 minus is phosphorus. There is a double bond oxygen. There is a single bond oxygen negative, oxygen negative, oxygen negative. Now what happens up here also? This double bond can shift from here to here. It can shift from here to here. So what will happen up? This is phosphorus, double bond oxygen, single bond oxygen negative, single bond oxygen negative, single bond oxygen negative. Here we can take up a double bond here, single bond oxygen negative, single bond oxygen negative, single bond oxygen negative. Here. Single bond oxygen negative. Now what happens up here? See, there's a negative, negative, negative charge. We'll draw up a equivalent structure. Equivalent structure, what is common? Then we have a 1 phosphorus common and 4 oxygens also common. We have 4 oxygens also common. Now what happens up here? We'll have a single bond, single bond, single bond, single bond. Clear? Now what happens up here? In this case, we have a negative, 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 negative charge. Okay. Now one double bond is being shared between 1, 2, 3, 4 locations. So we'll give 1/4 bond to this, 1/4 bond to this, 1/4 bond to this, 1/4 bond to this. So overall it will become 1. So here we'll give up a partial negative charge. Clear? So it will become 1 plus 1/4, which is 5/4. Clear? So what is the bond order? Bond order is 5/4. Every phosphorus and oxygen bond is 5/4 or 1.25. Is it clear? Now what happens up in next case? The next case which goes up from here, phosphorus, oxygen is there. Now if I drop this structure again, phosphorus, oxygen, 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 oxygen. Every oxygen will be having up a del negative, del negative, del negative, del negative charge. What is this del negative? How much is the total del negative? We have a 4 del negative. And what is the charge on all the oxygens? 1, 2, 3, minus 3 on everywhere. It is minus 3. See, minus 3. So it is 4 del negative is equals to minus 3. It is 3/4. So my structure will be phosphorus, clear? So it is minus 3/4, minus 3/4, minus 3/4, minus 3/4. This will be a case over here. Clear? This will be a structure. I think we'll end up today over here with these kind of Lewis dot structure and finding their bond order, finding out their resonating structure. We'll meet up in next class. Okay. That's all for the day. Thank you.